You know, that device in your hand, or on your lap, or sitting on your desk, it's the end result of a story that's literally 5,000 years in the making. Today, we're going to trace that journey, all the way from simple beads on a wire to the AI in the cloud. So, let's jump right in.
Okay, just to put this whole thing into perspective, think about it. 5,000 years ago, doing a calculation was a physical act. You literally had to move a bead. But today, it's like an invisible storm of electricity, firing off billions of times a second inside a tiny sliver of silicon. Getting from that bead to this chip wasn't just about making things smaller, it was about totally changing what it even means to calculate something.
So where did this whole thing even start? Well, for thousands of years, the big challenge was just to find a way to count that was better than our own 10 fingers. This first era, let's call it the mechanical era, was all about building machines with actual moving parts, gears, levers, and rods, to do the math for us.
What's really staggering when you look at this is the pace. I mean, we get the Abacus around 3000 BCE, and then things are pretty quiet for almost 4,500 years. Seriously. Then, in the 17th century, we finally get these cool mechanical calculators like the Pascaline. It was basically a shoebox full of gears built for accountants. A century after that, Charles Babbage dreams up his difference engine, this huge steam-powered beast designed to automatically calculate logarithm tables. The ambition was definitely growing, but it was all still powered by essentially clockwork.
And you see, that was the core idea for thousands of years. A computer was a machine that you could see and hear working. Every single calculation was a real physical action, a gear turning, a lever clicking into place. And that physical limitation, that's the key here, because that was the barrier that was about to be completely shattered.
The mechanical age was really hitting a physical wall. I mean, you can only make gears and levers move so fast. To get more power, computation needed a whole new kind of energy. It needed a literal spark. It needed electricity.
So this was the old way of doing things, right? A super complicated clockwork machine totally limited by how fast its physical parts could move. But what happens when you throw electricity into the mix? And this was the game changer. By combining electrical switches with all those mechanical parts, engineers created this amazing hybrid. All of a sudden, electricity wasn't just there to turn the gears. The flow of electricity itself became a part of the calculation. This let them reach speeds that were just physically impossible with gears alone.
This new approach gave us the absolute giants of early computing: the Z3, the Harvard Mark I, and of course the famous ENIAC. These things were just colossal. ENIAC weighed 30 tons and used over 18,000 vacuum tubes. They say that when they turned it on, the lights in parts of Philadelphia would actually dim. These were the true pioneers, proving that computation was possible on a scale no one had ever imagined.
Okay, so we had the power, but it was locked away inside these giant, room-sized brains. The next huge challenge was really a battle against size. The question was, how do you take the power of something like an ENIAC and make it small enough, fast enough, and cheap enough for an ordinary person to use? And then, from about the 50s to the 80s, innovation just went into total overdrive. First, the tiny transistor came along and replaced those big, hot, unreliable vacuum tubes. Then, engineers figured out how to cram thousands of those transistors onto a single integrated circuit, and that led directly to the microprocessor, an entire computer brain on one tiny chip. It was just this relentless cascade of making things smaller and smaller that finally made the personal computer possible. I mean, this chart says it all, doesn't it? In just 40 years, we went from computers that needed their own building to a machine that could sit right on your desk. And this shrinking process wasn't just about convenience. It was about making all that computing power affordable and accessible for the very first time. And that right there, that is the real revolution of this era. Computation was no longer something that only governments, militaries, or giant corporations could do. For the first time ever, this incredible power was accessible to individuals, to you and me. And it completely changed work, education, and creativity forever.
So, the computer made it to the desktop. What's next? Well, the whole story of evolution stopped being about the box itself and started being about what that box could connect to. The computer shifted from being a standalone device to being a portal to the entire world.
And that brings us right up to the era we're living in now, cloud computing. The big idea here is that the power and storage of your individual device just don't matter as much anymore. Through the internet, your computer can now tap into these massive data centers, accessing almost infinite processing power. In a way, your phone has become a terminal to a global supercomputer.
And you know what? That massive cloud infrastructure is what's powering all the AI you use every single day.
Every time you ask your phone a question or an app recognizes your face in a photo, you're not really using the processor in your pocket, you're using a supercomputer in the cloud. It's the direct descendant of that very first electrical leap, but now it's operating on a global scale.
So we've gone from beads on a rod all the way to a globally connected network of artificial intelligence. It's been an incredible journey. So where does it point us next?
This really is the core takeaway of this whole story. Computer history isn't just a series of random inventions. It's like a stack of building blocks. The smartphone rests on the block of the personal computer, which rests on the microprocessor, which rests on the transistor, and you can trace it all the way down to the simple physical logic of the abacus. Each generation is truly standing on the shoulders of the last.
And so that's where we'll end. The very first computers were built to answer really simple questions, like what is 5 plus 7? Today, we ask them to translate languages in real time, help discover new medicines, and even create art. So the evolution of the computer is really the evolution of the questions we ask it. And honestly, the most exciting part is just thinking about what we're going to ask it to calculate next.